Hello everyone, welcome to Chemazon-Complete Chemistry. So in this video we are going to see a very important video that is based on protection and deprotection of functional groups. So we are starting with protection and deprotection of alcohols. In this video we are going to see all these different functional groups that are used to protect alcohols and diols with a lot of examples as well. Okay, so the first question is, why exactly do we need protection of a functional group? Okay, that is important to understand that, and then we will learn how a protection and deprotection is done. So imagine this starting material here. I want to do a Grignard reaction at the ketone. Okay, electrophilic carbonyl carbon. I want to add a ketone. So will this reaction occur, and will I get the methyl CH3 minus group attacking at this carbonyl carbon? The answer is no. Why? Because this can act as a nucleophile and it can also act as a base. Okay, so here you can see there is this acidic proton. Okay, acidic proton means it can be easily removed. Okay, so this will act as a base and it will not act as a nucleophile. So this CH3 minus will pick up this proton and it will become methane. Okay, it will not act as a Grignard reagent. Okay, so it will pick up this proton from here and the Grignard reagent is quenched. Quenched means it will not react. At the desired ketone side, I want this Grignard reagent to add at the ketone. Okay, instead it is reacting with the alcohol. Because this proton is acidic, so it will act as a base and it will not act as a nucleophile. So why the protection is required? When you want one particular functional group to react, that is here it was a ketone that I wanted to react, but instead of ketone alcohol reacted. So what we have to do is, what is the solution for this? So first you add a protecting group at the functional group that you don't want to react. Okay, I don't want alcohol to react, so I protected the alcohol. Then I do the Grignard addition. Okay, ethyl magnesium bromide will add at the ketone, I will get the tertiary alcohol. Okay, and after the reaction at the desired site, that is execution of reaction on the other part of the molecule is done, then you remove the functional group. Okay, so in this video basically we are going to see what are the different protecting groups for alcohols and how they are removed, that is how the deprotection is taking place. Okay, so starting with the first protecting group, that is benzyl. Okay, this is phenyl. Okay, very important, there is a difference between benzyl and phenyl. This is phenyl, then when there is one more carbon, okay, next to the benzene, this is called as a benzylic carbon. So this entire group is called benzyl group. So how you do the protection? So the first thing in alcohol is you have to remove this H hydrogen. Okay, that is you want to do the proton abstraction, will be common in all the cases. So we use basically base. Okay, what is the role of base? It will abstract the proton or remove the proton. Then this will become O minus and that will undergo simple substitution reaction. Here we want benzyl to react, so we have taken benzyl bromide. Okay, O minus will attack here, Br will go away as a good leaving group, so we get the protected alcohol. And then when we want to do the deprotection, what we do? We do hydrogenolysis. Okay, this is called hydrogenolysis, or we can also call it as hydrogenation, palladium catalyzed hydrogenation. So basically this will break the CO bond and add hydrogens on both the sides, so we will get the alcohol back. Okay, so very important, Bn is benzyl and Bz, okay, don't get confused between Bn and Bz. Bz is benzoyl, that we'll see in the coming slide what is benzoyl. So this is benzyl is Bn, okay, not Bz. Bz is benzoyl. Okay, coming on to the next protecting group, that is para-methoxybenzyl, PMB group. Okay, why it is called PMB? At the para position of the benzyl group, there is methyl and oxy. So that is why it is called PMB group. So again you use PMB chloride and a base like triethylenamine. We will see the examples of base, what kind of bases can be used. Okay, so the protection is done, and how do you do a deprotection? You do the deprotection of PMB using a reagent called as DDQ. Okay, it is dichlorodicyanoquinone. What is the structure of this? We'll see in the coming slide. Okay, so basically this DDQ reagent is used to deprotect the PMB group. Next is trityl. What is trityl? carbon attached to 3 phenyl groups. Okay, this is called as a trityl group. So protection using trityl group, what you use? You use TRCl, that is trityl chloride and base. So protection, and then how you do deprotection. So basically this is an ether functional group. Always remember, to deprotect any kind of ethers, what is required? Acid hydrolysis. Okay, mostly we use acid hydrolysis, that is H3O plus, that will deprotect the ether. Okay, coming on to the next functional group. Now we come on to the silicon based protecting groups. Okay, alcohol is a can be protected using different silicon groups. So silicon will be common. These three groups attached to the silicon will differ. Okay, one bond is oxygen. Silicon belongs to which group? It belongs to group 14, that is carbon family. So silicon can also form 4 bond. One bond will always be with oxygen. Remaining 3 groups are different. Okay, these 3 groups are changed and you get different silyl protecting groups. Okay, so what do you use? Trimethylsilyl, TMS chloride. So again you use a base, you form O minus, O minus will attack here, Cl minus will be lost, you will get the TMS protected product. Now always remember, for the deprotection of silyl protecting groups, what do you use? You use a fluoride source, okay, fluoride ion F minus. Why? Because F minus, and it has a very strong affinity for oxygen. Okay, it has a very strong affinity for oxygen. Oxygen fluorine bond is very strong. Why? Because this can be used for a deprotection of this silicon. Why? Because this fluorine, it has a good affinity for silicon, okay, not oxygen, silicon. So this can donate its electron in the vacant d orbital of silicon, and then this will be lost as a good leaving group. So you get the alcohol brag. So always remember, this reagent tetrabutyl ammonium fluoride, TBAF. TBAF is used for deprotection of any silicon based protecting group. Okay, because bond between silicon and fluorine is stronger as compared to silicon and oxygen. So that is why this bond will easily break. Okay, another group. Next, you can protect alcohol as in the form of esters. Okay, you can form different esters by treating with acetyl chloride. You will get acetate protecting group. Benzoyl. Okay, this is the group that I was talking about. Benzoyl is benzene and carbonyl. Okay, this is BZ. And what is benzyl? Benzyl is BN. Okay, benzoyl is BZ. Then pivol oil. Pivol oil means tertiary butyl group is present. So these are the ester protecting groups. So what you do? Again, you use a base and then you use a respective acid halide. As for acetate, you use acetyl chloride. For benzoyl, you use benzoyl chloride. For pivol oil, you use pivol oil chloride. Okay, the only difference is the R group is changing. So you will get all these three protecting group. How you deprotect? So the forward reaction, we have learned this. This is esterification, reaction of alcohol with this thing. Okay, acid halide. We get the ester, and then you do hydrolysis. Hydrolysis, base mediated hydrolysis will give back the alcohol. Okay, base you can use ammonia. The next functional group is, you can also protect a diol. Okay, vicinal diol. Vicinal diol means 1 and 2. Okay, adjacent carbon, if there are two alcohol groups, that is vicinal diol, you can protect that using ketone. Okay, acetone, acetonide protection. That is why this is called acetonide protection. This compound that is formed is called acetonide. Okay, in presence of acid it will be protected, and then in presence of acid hydrolysis it will be deprotected and will get the diol back. Okay, coming on to the other ether functional groups, there is something called as MOM, methyl oxymethyl. Okay, methyl in CH3, oxymethyl. This is MOM, you use MOM chloride for the protection. Then there is THP, tetrahydropyran. This is the protecting group. Now what is exactly pyran? Pyran is this compound having two pi bonds, okay, oxygen, and then there are two double bonds. Then you reduce one double bond, okay, that is you add two hydrogen, that is called DHP, dihydropyran. Okay, you add two more hydrogen, reduce the other double bond as well, you will get THP, tetrahydropyran. So in the reaction here you will see for mom it is simple, you use this mom chloride and acid, it will be protected. And then for THP, the reagent that you use is DHP. So oxygen will attack at this position and this double bond will break. So you use DHP, but the protecting group that you get is THP, okay, tetrahydropyran. And then again I told you ether, they can be easily deprotected using acid hydrolysis. Okay, this is another ether protection that is called MEM. Okay, that is methoxy ethoxy methyl. See, methoxy, then ethoxy, eth means 2 carbon oxy methyl, methoxy ethoxy methyl, that is why it is called MEM. Okay, base you use sodium hydride, it will form the salt, then this O minus will attack here, chloride will be lost, and then you do the deprotection using Lewis acid, that is zinc bromide, or you can use this PPTS, this is also a Lewis acid, you will get the alcohol back. Okay, and then and how do you deprotect a THP group? This is an example of deprotection of THP. You use acetic acid in presence of water, that is I told you ether can be deprotected using acid hydrolysis. Okay, another silyl protecting group is called as TBS or TBDMS. What does this stand for? Tertiary butyl dimethyl silyl. So silyl tertiary butyl group is present, di means 2, methyl means 2 methyl group. So this is a TBDMS group, or sometimes it is also called as TBS. Okay, don't get confused between TBS and TMS. TMS was trimethyl silyl. This is tertiary butyl dimethyl silyl. Okay, so again you protect, imidazole is used as a base, DMAP is, I will show the structure of DMAP in the coming slide, it is used as a catalyst, and this TBS chloride is used as a reagent. You get the protection, again you do deprotection using TBAF. Okay, or there is another option, you can use 2,6-lutidine as the base. Okay, this structure also I will show you in the coming slide. Deprotection using fluoride. Next, TES protection. Again here they have used, instead of chloride they have used OTF as a good living group. Okay, TMS OTF, and 2,6-lutidine is used as a base. So this OH is protected with TES group. This is triethyl silyl. Okay, all the 3 groups you can see they are ethyl groups. Then there is something called as thexyl dimethyl silyl ethers, TDS group. Now what is TDS group? T thexyl, D for dimethyl silyl. So this group is called as a thexyl group. Then there are 2 methyl group, silicon chloride. So this is called thexyl dimethyl silyl chloride. Why this is used? It is cheaper as compared to TBS chloride. The only disadvantage is that after protection, when you do the deep protection, it reacts slowly under hydrolytic condition than the TBS protected alcohol, okay, TBS protected ether. That is the only disadvantage, but the advantage of using this is it is a liquid and it is less expensive as compared to TBS. So these are the 2 methods by which you can do this TDS protection. Either use imidazole as a base, or you can use butyl lithium as a base. You form the ROLI and then you react it with the this compound, okay, and then TDS chloride, and then you will get the product. Okay, another silyl protecting group that is called as TIPS, triisopropyl silyl. So silicon is attached to 3 isopropyl group. Imidazole is used as a base. Again for the deprotection you use TBAF. Okay, one more protecting group, silyl protecting group is TBDPS. TBDPS, tertiary butyl diphenyl silyl ether. It is also called as TBDPS or BPS. Okay, so you use TBDPS chloride, then protect, again deprotection using TBAF. Now this protecting groups, now which protecting group you have to select, okay, that depends basically on the alcohol that you have, okay, alcohol that you have. So we start with the cheapest one, okay, the commercially available cheapest most widely used protecting group, and if that doesn't work then you find out the alternative. That is how you do the alcohol protection, okay. And it also depend on the medium that you are working on, okay, whether it is acidic or basic, the protection depends on that as well, okay. So now we'll see some of the examples, okay. Alcohol protected using PMB chloride and ethylamine is used as a base, and DMAP is used as a catalyst. So you get the protected PMB ether. Then you do D protection using DDQ. So this is a structure of DDQ. D stands for dichloro, dicyano and quinone. Dichloro, dicyano, quinone. This is DDQ, that is used for the protection of deprotection of PMB group. Now there is one problem, that DMAP that we use, this is quite toxic. So there is a safer alternative for this, that is we can use DABCO, this compound as a catalyst. That is, what does this stand for? Diazo. Di means two, azo means two nitrogens, bicyclo. Okay, this is a bicyclic compound, and cyclooctane. Why octane? You start numbering from here 1, 2, 3, 4, 5, 6, 7 and 8. Okay, so octane, cyclooctane, this is the compound that you can use instead of DMAP. Now next question, here there are two alcohols, secondary and primary alcohol. So you treat it with this trityl chloride, okay, TRCl that we had seen. Ethylamine is used as a base. So selectively only primary alcohol will be protected, as it is less sterically hindered as compared to the secondary. So primary alcohol will be protected. Okay, the next, this example is how do you do the deprotection of the trityl group using, this is again an ether. So use a acid, okay, acid hydrolysis. You use formic acid and water, the trityl group is deprotected. Okay, so this is the structure of the base that I had mentioned. 2,6-lutidine is nothing but, you start numbering from here 1, 2, 3, 4, 5, 6. 2,6-dimethyl pyridine. Okay, that is 2,6-lutidine, and this is another bulky base that is called DBU. Okay, this is the last question. So here this compound is given. There are three protecting groups, and the question is, you have to provide the three different deprotection conditions by which all these three groups can be deprotected. Now TBS, okay, what is TBS? Tertiary butyl dimethyl silyl group. So silicon, I told you what silicon deprotection, what do you use? For silicon deprotection you use TBAF as the deprotecting agent. Then this is tetrahydropyran, this is ether. For this what you use? You use any Lewis acid. You use any acid hydrolysis condition for removal of, for hydrolysis of ether. And then MEM, this we had seen, for this group we use zinc bromide or any Lewis acid. So what is the answer? So for TBS removal you use TBAF. For THP you use acetic acid in presence of water, that is acid hydrolysis. For MEM group, MEM group, you use titanium tetrachloride or zinc bromide, that is a Lewis acid. Okay, so that's it for this video. I hope you have understood the reason why you do a protection of any functional group, what are the different protecting groups for alcohols, and how do you do the deprotection. Okay, in the further videos we will solve some problems related to this protection of alcohols, and we will also see protecting groups for other functional groups like carboxylic acids, amines and so on. Thank you.